Hello geometry and welcome to the second video for this week. This is all about the angle bisector theorem. Now this is a little misleading in a couple of ways, and I'll admit with the academic language here, I would not be able to understand this without already knowing the answer just by reading this. But ladies and gentlemen, for those of you who might have read it or already understood it, let me go ahead and explain it just one more time. So the angle bisector theorem is the fact that the angle bisector of a triangle will divide the opposite side into two parts that are proportional to the other two sides of the triangle. So let me actually draw it out so we can kind of add a picture to all this. Ladies and gentlemen, it starts with a triangle. And then you pick one of the sides. I'll go ahead and pick this part right here, this angle. And that angle, if cut in half, will proportionally divide the opposite side. Because remember, the opposite means across. So let's go ahead and cut this angle in half. I'm just going to sketch it. So there's about halfway. So these two parts of the angle are congruent, meaning they're the same. So by doing that, I have cut the full opposite side into two parts. Those two parts, I'm going to go ahead and label it, A and B, are proportional to the other two sides of the triangle. I'm going to go ahead and label it X and Y. So what we've done is we've created a matching scenario, a correspondence. And with that correspondence, we can create our proportions. Ladies and gentlemen, one of the things that's hard about the angle bisector theorem, that even with the side splitter theorem is even more abruptly apparent, is the fact that there is no similar triangles here. There is no similar triangles. This isn't even an altitude like in our right triangle similarity relationships from last week. This diagram has literally zero similarity pieces to it. And so that does not take away from the proportionality. So, ladies and gentlemen, what we've been saying so far this semester for this unit is that scale factor, ratio, and proportion are all synonyms. What we're doing right now, though, in this particular week is we're taking away the scale factor. Scale factor is not a part of this because of the fact we don't have similarity. So instead, just ratio and proportions are what we're working with. We're still working with the fact that they're proportionally related. As one gets bigger, the other one's going to get bigger by the same factor. It's just not a scale factor because of the fact that we don't have a dilation. And so, when we compare this, we're still going to compare it with matching. And so we could match A with B and set that equal to X with Y. And ladies and gentlemen, why is the X on top? That was actually a little punny right there. The reason why X is on top is because it's on the same side as A. It's adjacent to A with our angle bisector. And so that means we could write this instead as A over X equal to B over Y. Notice A and B are on top because they're both the segmented side. X and Y are on the bottom because those are the corresponding other sides to create our proportion. So, ladies and gentlemen, let's go ahead and put this with some practice and an example. All right, ladies and gentlemen, so in this diagram, we have our 9, our X, our 3, and our 4. One thing I haven't made apparent yet that I need to kind of point out is that your angle bisector doesn't have to stop at this side. It doesn't have to stop right here. It could continue and just be a really, really long line past it, and everything about the problem stays the same. So whether it continues past it as a really, really long ray, or if it stops, either way, Same problem, because an angle bisector is intersecting the opposite side, creating a proportional relationship. So ladies and gentlemen, all we need to do is match. And because of the fact we are not dealing with a similarity statement, we're not dealing with similar triangles, however you match it is wonderful, fantastic, and fine. So I'm going to put x on top because, you know, I love having x on top. Makes it so much easier to solve. And its corresponding side is the 9. X also matches with the 4 because they're on the same sides. And so whether you put x over the 4 or if you put x over the 9, you're going to be in great shape either way. So I'm going to go ahead and put x over 4, which then means I have the 9 over 3. And ladies and gentlemen, from here we can solve. I'm going to go ahead and just simplify my 9 over 3 first, because 9 divided by 3 is 3. So 3 is equal to x over 4. And from here we can multiply by 4 on both sides to mean x is 12. Perfect. Let's take a look at another example. All right, ladies and gentlemen, so looking at this next example, we have ourselves a triangle that's a little more rotated than it was before. We're picking another angle that's being bisected, but that's all right because this is all proportional. Ladies and gentlemen, let me repeat that. This opposite side is not cut in half. The angle is cut in half, which makes the opposite side proportional. So this x minus 4 does not equal 6. Just like up above, this 3 and 4 was different. It is not bisected. The opposite side is not bisected, all because the angle's bisected. The connection and relationship is that a bisected angle gives you proportional sides. And so what we know then is the x minus 4 is proportional to our 6. And the x minus 4 is proportional to our 18. And so, ladies and gentlemen, that means when we go to set this up, I'm going to put the x minus 4 on top because I like having my x's on top, as that helps me solve the problem. And I'm going to go ahead and match that up with the 18. And that's going to be equal to the 6 over the 12. And so, ladies and gentlemen, solving from here, I'm going to go ahead and multiply by the 18 on both sides, get rid of the fraction. The 18s are going to cancel out, which means you have the x minus 4 equal to 6 times 18 divided by 12. But ladies and gentlemen, I have some good news. 6 divided by 12 is 1/2. 1/2 times 18 is 9, which means our value of x, when we add by 4 on both sides, is 13. Once again, as a reminder, if you watched the last video, 13 is not the length of this side. X minus 4 is the length of this chunk. 13 is not x minus 4. 9 is what you got from x minus 4. 13 minus 4 is 9. So this side, this length is 9, but our value of x to get that is 13. The reason why I point that out is because sometimes you'll be asked to solve for x, sometimes you'll be asked to find the length of the missing side, and that's the difference. So, ladies and gentlemen, let's go and look at one more practice problem. All right, ladies and gentlemen, so in this next example, I did draw the line to be extended just so that you have an example where we're working through it and you see that. But ladies and gentlemen, more importantly, in this example, we have an x and an x plus 3. So, how are we going to solve this? The same way we've solved everything else. We're going to match our correspondence, make sure our correspondence is correct, our matching is correct, and then we're going to solve by multiplying away our fractions. And so, ladies and gentlemen, let's go ahead and plan to put our x's on top. So, this is one of them, this is the other one, and what do those match with? The 21 and the 14. And so x plus 3 matches with the 21 because they're on one side of that angle bisector. And that's going to be equal to the x over the 14 because x and 14 are on the other side of the angle bisector. Now, let's start taking care of our division with multiplication. So we're going to choose to multiply by the bottoms on both sides. Because of the fact we have two x's, it doesn't really matter which side you're going to multiply by first. I want to choose to multiply by 21 just because I can. So on the side with the x plus 3, the 21's cancel out, which leaves x plus 3 equal to 21x divided by 14. Multiplying the x by 21, then the 21 does not multiply by 14 on the bottom because the 14 is being divided. So from here, ladies and gentlemen, we actually have two choices. 21 and 14 are both divisible by 7. So we could reduce this fraction. Even though it might not completely get rid of the denominator, it will make the denominator a smaller number and easier to work with. Or we could just multiply by 14 on the other side and worry about that later. I am going to choose to reduce the fraction now because smaller numbers means we get to work through the problem a little bit easier and a little bit faster because we can rely on our mental math a little bit more effectively. And so both 21 and 14 are divisible by 7, which means I have 3x over 2 in reality, rather than 21x over 14. And our next step in order to solve is to undo our division with multiplication. So I'm going to multiply by 2 on both sides. And when I multiply by 2 on the side with the x plus 3, that 2 is being distributed to the whole thing because of the plus sign. So the 2 gets multiplied and distributed to the x and 3. So I have 2x plus 6 equal to 3x. Now, we have x's on both sides still, which means we're going to combine our x's rather than our regular numbers. So what are we subtracting by? Not the 6. We're subtracting by the 2x on both sides. The 2x's on side with the 6 are going to cancel out, which means our value of 6 is equal to x. And ladies and gentlemen, that value of x has been solved. So what are the lengths of the sides? Just in case we were asked that. 6, but the other one is 6 plus 3 to equal 9. So, ladies and gentlemen, just so that you're keeping aware and keeping track of it, this chunk here that corresponds to 14 is 6. The chunk above that corresponds to 21 is 9. So, ladies and gentlemen, with that being said, I hope that answers the majority of your questions. If you do have any other questions or concerns, please email me. I'll be more than glad to help. And I look forward to seeing you guys all later this week. Take care. Looking forward to seeing you all soon.